All right, ladies and gentlemen, 6-3. So lesson 6-3 is about triangles. And can you recognize a triangle or can you draw a triangle given some angles or some side lengths? Okay, so there's a couple things that we have to go over. This one, unfortunately, is going to be a little long because there's some things I have to cover before moving on, but I will try to get through it as efficiently as possible. So let's start with this.
How are all triangles with the same side lengths alike? Think about this question during the lesson. Students in woodshop class are measuring and cutting out a triangular base for a corner shelf, with sides measuring 6 inches, 8 inches, and 10 inches. How can you determine if all the students will cut out the same triangle? Explain. Let's see if we can find a relationship between the triangles. Does the orientation of a triangle change its shape?
All right, so the first thing it wants to say is if we look at this triangle here, right, this is where my mouse is circling. Okay, so that triangle has a side of 6, 8, and 10. And then there's this triangle over here, and it has a side of 6, 8, and 10. And then there's this triangle over here, and it has a side length of 6, 8, and 10 as well. What it's asking is, are these all the same triangle? And how do you know? Okay, so if we just look at them, does the orientation of a triangle change? So because this one is, all right, it looks like an L. Okay, we'll call this the L going this way. Okay, then we look at this one here, and it's not an L, but we can see that L right there. It's just kind of fallen over. Okay, he got a little tired. He fell over. He can't hang anymore. Okay, then we see this L. Oh, man, he's back and rested. He is standing up tall. Okay, are they still the same triangle? These three triangles, are they the same? Well, essentially, yes, they are. Okay, because they have all of the same side lengths. And they all have this right angle. Okay, one right angle, all the angles are going to be the same if all the sides are the same. So just because we turn a triangle upside down or sideways doesn't change the triangle.
Use geometry software to draw and compare triangles with the given side lengths.
Okay, if you wanted to try this, let me know, because the Pearson has tools. So my math tools are up here. We're going to click on this. We would go to 2D geometry and we would do triangle conditions. Okay, so in here in this drop down it says, what does a triangle look like given one side? If we know what one side of that triangle looks like, or two sides and an included angle, or two angles and one side. Okay, you can play around with the software. I might just have to try to find it on the student side, but it's there if you wanted to play around with it. So I'm going to close back out of here. Okay, so this is an example of, here's a triangle given two angles and one side. Okay, so the way that we talk about angles, this is something that's a little extra that I have to go over as a refresher. So the way that we talk about triangles and angles, okay, this is triangle ABC. You can see because its 3 points are labeled ABC. So it's called triangle ABC. Okay, when we go to look at the sides, so side AB, that's this one right here. This is side AB. There's side AC, that's this side over here, and then there's side BC, which is this side over here. If we're talking about the measurement of angle ABC, the letter that starts is the starting, and then you go B is the vertex, and then C is the other ray. Okay, so this one here, the measure of angle BAC, that's talking about this angle right here, is 28.1. The measurement of angle ACB, which is ACB, so the measure of this angle here is 91.1, and the measure of angle ABC, so this one right here is 60.8. So that's kind of how we talk about triangles. They're named by the blank in here, label, there we go, label of the angles, and then we call angles and sides by their letters as well. So hopefully that will help as we get into it.
You can turn the triangles so they fit exactly on each other. Do all triangles with side lengths 6 units, 8 units, and 10 units have the same shape and size?
Select your answer.
Okay, we just talked about, are these three triangles the same? They all have the same sides, but because we change which way it's standing up, does that change the triangle? Well, no, they are still all the same triangle.
If triangles have the same side lengths, then they have the same shape and size, no matter how they are positioned. So, all the students will cut out the same triangle.
Okay, so sort the triangles to show which ones have the same size and shape. Well, here's a 3, 6, 5. So if I say that's going to be our same size one, I'm going to find 3, 6, 5 and 3, 6, 5. Okay, those are all the same triangles. This one's not because it's 3, 5, 4. This one's definitely not. We can tell just by looking at it, and this one as well. This is a obtuse triangle, and these ones are definitely all acute. All right, so if we look at this, how many unique triangles can be drawn with the given side lengths of 8, 10.3, and 13? Well, we just learned that there is only one way to draw a triangle with the side lengths of 8, 10.3, and 13. So one unique triangle can be drawn. Then it says when two sides of a triangle are switched, why is it still considered the same triangle? Okay, so if we think about this here, if we have a triangle that's 13.3, 10, that's not going to work, 10.3, 8, and 13. We'll say this, 10.3, 8, and 13. Why would that still be the same if we drew it this way, 13, 10.3, 8? Why is it still considered the same triangle? Well, because the side lengths are all the same. This should be touching. The side lengths are all the same. Here's a 13, here's a 13, here's an 8, here's an 8, 10.3, 10.3. It's the exact same triangle no matter what way you turn that triangle around. You're going to get the same thing still. I've forgotten where all my tools are. All right, so let's move on here to our example 2. All right, example 2 says, Steve gathers 3 pieces of wood from the scrap pile in woodshop class. Can Steve make a triangle with these 3 wood pieces? All right, so if we had the 8 feet wood piece here, and then we had 4 feet, and then we would only have 3. Okay, that's not going to touch. If we do 8 as the hypotenuse, we do 4, and we do 3. No, not going to touch. Okay, so Steve cannot make a triangle with these 3 pieces of wood. Okay, the reason he can't is because the 3-foot and 4-foot wood pieces are not long enough to form a triangle because 3 plus 4 is less than 8. Okay, so something that we can think about is that when you are trying to construct a triangle, you have 3 sides here, right? We had 1, 2, 3. Okay, we learned that right here, the 2 shorter sides have to be equal to or greater than that other side. Okay, so the 2 short sides have to be greater than or equal to the longest side. Okay, remember that 2 short sides must be together. 2 short sides combined together, added. We'll write add here. Have to add to be greater than or equal to the longest side, or you cannot make a triangle. I don't know what just happened on the screen. I know I switched. Oh, generalize what you can conclude about the lengths that make a triangle possible. Oh, well, we kind of just did that. Let's see if it gives us the answer. The sum of the lengths of the 2 shortest sides must be greater than the length of the 3rd side in order to form a triangle. Ingrain that into your brains. 3. Can more than one triangle be drawn with the following conditions? Side lengths of 5 and 6. All right, 5, 6. with an included angle of 45 degrees. Well, if I pretended that this was 90, and the only other way to put that triangle would be that. So one of those would have to be 45. This one looks about half of 90. If we say that's 45, can this one over here, is it 45 as well? It would have to be in order to form a triangle. Okay, if I did, I really suck at drawing different kinds of triangles. 5 and 6. So we got an obtuse angle there. Draw this last line. If this is 5 and this is 6, could one of these ones be 45? Okay. So you're just trying to think of the different ways that we can draw triangles. Whoops. So let's see what this one says here. Erase. Get this out of the way. All right, so draw a 45-degree angle is what it says with the line segments of 5 and 6 inches. So here's their angle, 45-degree angle, with a side length of 5 and a side length of 6. Okay, so we go next, connect those two by the last line, and then is there more than one way to connect the two ends of the given sides? No, only one triangle can be drawn with the given measures of 45 degrees, 5 and 6. So compasses are really going to come into play here. I should have one in every pouch over on the side for you to use if you need to draw out some of these triangles. Can more than one triangle be drawn with the following conditions? Side length of 6 with angles at each end measuring 40 and 60. Okay, so it said step 1, draw that side, draw a 6-inch line, then draw an angle of 40, and then draw an angle of 60, and will they connect to form a triangle? They will, in this one as well. So yes, you can draw one at least. Is there more than one way to do the other one? No, only one triangle be drawn with the given measures. 3, write 3 side lengths that will form a triangle. So this is from earlier that we were talking about. Will form a triangle, a side of, so if we have triangle ABC, we can do AB is 7, AC is 10, and BC is 18. Okay, that will form a triangle. One that will not, so we can have triangle XYZ, and we can have line XY4, XZ3, and YZ14. That will not make a triangle because the two shorter sides do not add to B14. However, these ones add to be, oh, lame, can't do it either. See, everyone messes up. 10 and 8. 10 and 8 can add to be 18, so it can, sorry guys, everyone makes mistakes. I found my mistake though, that's the biggest thing. But this one will not form a triangle because 4 plus 3 is not greater than 14. Can a triangle be drawn with a side length of 3 inches with angles at each end measuring 90 and 89? All right, so here's, do I have geometry? I don't think so. So if we have 3 inches right there, 90 is straight up. I know that. 89 is going to be slightly not straight up. Will that ever form a triangle? No, it will not. That is a cup. It will not form a triangle. Okay, so one more thing, I want to do a couple of the practice problems because they're a little different than this stuff. So if I click over to here and look at this question, yes, I'm going to erase all of that. We look at this first question here. Now, remember to take notes. Remember this question or go answer it when you're done here. All right, so this one says, form triangle QRS where measure of QSR is 65, measure of angle SQR is 50, and QR is 7. Okay, so if I looked at that first one, well, both of them, okay, which of these 3 triangles are going to give me that? Okay, well, I know for sure that this one's not. Okay, why is it not? Insert Edpuzzle question. All right, hopefully you said because not one of these sides is 7 units. This one is 1, 2, 3. This one is 1, 2, and a little bit. That one's 2 point. So no, it's not this one because it doesn't meet the side lengths. Okay, which leaves us to A and B. Can we get side QR, so it's the bottom of the triangle on both of these, is it 7 units? So we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So yes, those two both have side QR, that is 7 units. Next we have to do the angles. So angle QSR, remember that one, the letter in the middle is the vertex, okay? So we have angle QSR, QSR. Is QSR 65? Maybe. Okay, I can't immediately eliminate it right now unless I got out a compass and figured it out, protractor, and figured it out. So let's do this one, SQR. Let's see if I can switch colors so it's not so confusing. SQR, SQR. Okay, is one of those definitely not 50 degrees? This one, SQR is not 50 degrees in that one. It's like 90-ish. So we know it's not B, which eliminates 2 out of the 3, which gives us the answer of A. Okay, so that's how we're going to try to go over some of these questions. Try to do a process of elimination. Which one is it definitely not? And then try to work yourself backwards from there. Okay, so remember how we name triangles by their letters, how we name the angles, and that the 2 shorter sides must be greater than the longest side in order to make a triangle.